computation this time. That's why I already asked the teacher Cosette, no, that I'll extend for this day. No? Okay, so let's start already. So for this afternoon, let us have a recall. What are the types of the spherical mirror? Anyone from the group? What are the two types of the spherical mirror? Yes, Nathaniel.
Concave and convex po.
Concave and convex. What is the other term for concave and convex mirror? Okay, yes, Kevin.
Converging and diverging mirror.
Okay, converging and diverging. Is it loud, my voice? Loud and clear? Okay, so converging and diverging are the two types, or concave or convex. Okay, now how will you differentiate concave and convex mirror, or diverging and converging? Okay, yes, Gian.
Concave is the reflecting surface is curved inward, whereas the convex mirror is the reflecting surface is curved outward.
Okay, very good. Okay, can you give me some example of the concave mirror? Huh? What are the example of this concave mirror? Of course, if it is plain mirror, it's there in your house already. But what are the example of concave mirror? Concave per sa concave. Can you give me an example of concave mirror? Anyone from the group who can give me an example of a concave mirror? Yes, Pawi. Yes, the headlights that we can see, especially in the vehicle. What else? Any other example of a concave mirror? Who's that one? Abigail Bancod.
Sir, try only. The mirrors in the store where you can see it in the farther corners po.
The mirror in the store. Is that a concave? Remember a concave. Cave, ha? Cave. Okay. So, what is the other example of the concave mirror? I think the one in the store, especially in the 7-Eleven, that is an example of what? Convex. Very good. That is an example of convex. Yes, Roy Banyares.
A spoon po, sir.
The spoon, okay? Spoon. Actually, it's two for the spoon. Here's the concave and here's the convex, no? What else? Gabi Teng.
Yung side mirrors po.
Side mirrors. Yes, side mirrors is an example of the concave mirror. Okay? What else? Huh? What else? Any other hand? Yes, Enzo.
In the flashlight po.
Flashlights, very good. Flashlights is an example of a concave mirror. So we have already the head mirrors, no, or the headlight mirrors. Okay, what else? The side mirrors. Okay, the flashlight. What else? Okay, what else are example of this concave mirror? Yes, Eric Jacob Cruz.
Ano po, eyeglasses po for nearsighted po.
Okay. The eyeglasses for the nearsighted. Yes, that is an example. Okay. Any other? Yes, Anabo? You want to say something?
How about the the one that dentists use to see the
The
teeth?
one that dentists use. Okay, so that it will be bigger. Okay. Is that a concave or convex? Huh? Is dentist mirror a concave or a convex? Okay. So dentists use actually a concave mirror. What do you think is the reason why the dentist is using a concave mirror in our teeth? Huh? What's the reason why the dentists are using a concave mirror? Yes, Roy Banyares. What's the reason why the dentists are using concave mirror? Huh? You know what is that one? the small one, ha? Just like this, and then with small mirror here. Did you know that one? And then they will check. Yes, Roy, what's the reason?
For a wider view po, sir. For the
Okay,
mouth.
for a wider view. Okay, so that they can see our teeth and the other areas in the mouth. Okay, so that's the one. So they can see really largely, no, or bigger the figure or whatever the dentist is examining in our mouth. What about for the convex? Okay, one example is the mirror in the 7-Eleven, no, in the Mercury. Okay, so that is an example. Okay, aside from that one, any other example of the convex mirror? Okay, someone is raising the hand. Who's that one? Yes, Rancap.
Magnifying glass po.
Magnifying glass. Very good. What else? Etchon.
Sir, telescopes po.
Telescope. Okay, what else? Huh? Convex. Okay. Some of the side mirrors are using the convex, no? Okay, convex mirror. Usually, most of the optical instrument, no, are using convex mirror. Actually, in camera before, no, they're using the small lenses in order to see. We have the fish eye, something like that, no, so that they can see largely or very small, no, just like the angle of the camera. So those are the example of the convex and concave mirror. Okay, now what are the different parts of the mirror? Can you give me again the different parts of the mirror, the one that we discussed last time? Anyone? No one? Isn't it? We're done with the different parts of the mirror. What are the different parts of the mirror that we discussed last time? Yes, Aldea Manipon.
Should I just give one, sir?
All already because it seems that they don't like to answer it.
First of all, the center of curvature, and we have the principal axis, and then the principal focus, and then the radius of the curvature and the pole.
Very good. Okay. Did Aldea miss something? Huh? Okay. So can you repeat that one? Yes. Maria Ana, class number 32.
Sir, the center of curvature on the center of curvature, the principal focus.
Where can we see the center of curvature? And then upon telling principal axis, you're seeing already or you're imagining already where can we see that principal axis? Where can we see that vertex, the radius of curvature, the focal length? Okay? You can visualize already so that if Sir Alex will ask you to draw, then it will be easy for you. Okay? Next question. Okay? What about the ray diagram? What's the purpose of this ray diagram? Hmm? Since we discussed also that one. Yes, Sarah, Marie, Anabo.
It is a way to determine the location and character.
is to visualize or describe the characteristics of each image. Okay? So each number of object in the design particles into each point is number one. Each number one is also described LOS. The object is an image. Okay? So the object or the image in this one is visible. Yes. That's why the image observed is number one. If it is infinite, then that's okay. But if it is number two, object looking to be the center of curvature, it is the object and this is the image. Okay? So when you describe characteristics that of the image, image, behind the center of the angle, but it is the image. First thing is the one. Yes, characteristics of the line. Okay, very good. In the center of curvature and focus. Okay, that's the location. Between the C and C is the image inverted one. Okay. We describe the orientation is inverted. Very good. Okay. What about the size of the image, Micaela?
Smaller than the object po.
Okay, smaller than the object. Very good. And the type is, of course, center of curvature. So here is the figure. Now let's describe the characteristic of image. Okay, how will you describe the location of the image? Anyone from the group? Yes, Neil. Where is the location of the image found?
It's in the curvature.
Okay, it is in the center of curvature. Very good. Okay, what about the orientation? Where can we see the orientation? Look at the image. Huh? Yes, Mamba.
Inverted.
Okay, it is inverted. What about the size of the image? What can you say about the size of the image? Ren Santos.
Same size po.
Same size as the
Object po.
okay, same size as the object. What about the type of image? What is the type of the image here? Chanel.
Real image po.
Okay, it is real image. Are you sure?
Yes po.
Okay, why real image, Chanel? Huh? Why real image? Because it is Chanel. Yes, very good, Gian. Because it is inverted, that's why it's a real image. Okay, that's the one. Okay, next, case number 4. Case number 4 is object is located between the center of curvature and the focus. Now, here is the figure. Let us describe the characteristic of image in case number 4. Now, look at this one. Here is your object and here is your image. Let's describe the image. Location. Where can we find the location? Yes, Gian.
Beyond the center of
Very
curvature.
good. It is beyond the center of curvature or nasa likod daw siya ng center of curvature, which is true, isn't it? Here's the intersection. Okay? So what about, this way. So location is located beyond the center of curvature. What about the orientation? What can you say about the orientation of the image? Gabero?
It's upside down po.
Upside down? Or
Inverted.
inverted. There. It is inverted. Okay. What about the size of the image? May I hear the voice of, yes, Cyril Mambat?
Larger than the object.
Larger than the object. Very good. It is larger than the object. And the type of the image is, Lara?
It's real image po.
Real image. Okay. Why real image, Lara?
Because the orientation is inverted.
Very good. So it's real image. So remember, case number 4, object is located between the center of curvature and focus. Let's go to case number 5. Case number 5, the object at the principal focus, or the object is located at the principal focus. Okay, so let us check the figure. This is the object, this one. You can see the arrow. You can see the mouse pointer. This is the object. Now let's describe this case number 5. Okay, what can you say about their loss? The location of the image. Do we have? Yes, Gab Biteng?
No image found po.
There will be no image. Okay, why? Why do you think there's no image here in the principal focus? Yes, Mama Riel, Pawi? Okay, because they are all parallel and you cannot see any intersection between the ray 1, ray 2. Okay? You get the point? Okay. Next. I don't know if I have case number 6. So we still have case number 6. Object is located between the principal focus and the mirror. Here we go. So look at this one, Okay. So it's just like when you put nearer your spoon, using the concave mirror or concave part of the spoon, then you can see that the image is like that. Okay, you can see here. Okay. So at first you will see in the spoon part, which is the concave part, that your image is always inverted. But upon, or if it is nearer to your face, the mirror, then you can see that the object is what? Erected. Okay, it's not inverted. That's why let us describe the characteristic of the image. Let's talk about the location. What can you say about the location of the image? Here. Okay, here's the image, isn't it? So where can we find the image? Yes, Jake, where can we find the image? Hello, Jake.
The image is in the in front of the focal point.
Okay, in front of the focal point. Okay, so the image is located behind the mirror. Okay, parang nasa likod siya. Okay, what about the orientation? What can you say about the orientation here? Oh, look at the image. Yes, Denise Rosalan.
It's upright po.
Okay, if it is upright or erected, isn't it? What about the size of the image? Look at the size of the image. Yes, Ranyola.
Bigger than the object.
Bigger than the object. Very good. Or larger than the object. What about the type of image? Okay. Any other hand aside from these people who keep on raising their hand? Very good. Thank you so much for being active. Yes, Eric.
Virtual po.
Virtual. Why virtual, Eric?
Because it's upward or upright po.
Upward or upright?
Uh, upright po.
Upright. Okay, it is virtual because the image that is formed in case number 6 is upright or erect. Okay? Question with a different case number 1 to 6. None? Okay, so if none, then let's proceed already with this one. Now, how do you know if the image is real and virtual? Huh? That's my question to you. Roy Banyares, would you mind to turn on your camera, Roy? How would you differentiate or how would you know that that is virtual or real image?
Sir, pass po. I have no idea po.
I keep on asking a while ago that one to you. Chanel.
Sir, the real image po will always be inverted. Meanwhile, the virtual po will always stay upright po.
Okay, very good, Chanel. Okay, so look at this one. Real image is always inverted, while virtual is always upright. Then in terms of the computation, always remember, real image is positive value of the distance image, or meaning to say, the DI is positive, while the virtual image is always negative, the DI. Okay? Then on the other hand, real image is has a negative value of the height image or the HI, meaning to say it is inverted, therefore that is a real image. On the other side, the virtual HI or the height of the image is positive because that is upright. Okay, what about for the magnification? Cyril, what can you say about the magnification of the real and virtual? Cyril?
It's the real image is negative and the virtual image is positive.
Okay, the real image, if we're talking about magnification, it is negative. While if the magnification is positive, then that is virtual image. Okay, they're giving you cue. Then, real image form in front of a curved mirror and can be projected on the screen. While the virtual form at the back of a curved mirror and cannot be projected. So that's the difference between real and virtual image. Don't forget these things, my dear people of the Philippines, because we will use this one in magnification equation. Okay po ba? Is it clear to you already the case 1 to 6 and this real and virtual? Who's this one? Luis. Only now you will enter. Now let's get it on with mirror equation already. So let's try this one. So when we say mirror equation, it indicates the simple relationship among the object distance or the DO and the image distance, which is the DI, and the focal length or the F of a curved mirror. And the formula, or aside from that one, it is applicable for both concave and convex mirror. Meaning to say, this formula, it's not only for convex or not only for concave, but both. Okay? So, the formula, okay, here, no, need to remember, we have this one. This is the object on the upper part and the image is the color blue or on the lower part. Okay? So, aside from that one, here, okay, we have the DO, distance of the object, and this one is the distance of the image, and this is the focal length, and this is the DI, or the distance of the image, and this is the focal length. Okay? Is it clear? What do you call to this line? What is this line again? Yes, Aldea.
Principal axis po.
Very good. What do you call to this letter F? Yes, Antoinette.
Principal focus.
Very good. What about this F? What is this F? Yes, Joshua?
Focal length po.
Focal length. What about this DI? What is DI? Carl, Justin. DI is dance instructor. Huh? Is that dance instructor? The DI? What is DI? Roy, what's DI? Roy. What's DI? Jordan, Clyde, Diana.
Distance image po.
Okay, the image of the distance or distance image. What about the letter C? Neil. Class number 1?
Curvature.
Okay, what kind of curvature? Center of curvature. And Princess, what is DO?
Distance of the object.
Very good. That's the distance of the object. So I hope everything is clear to you. No? So please remember also the sign convention in the mirror formula. If it is concave mirror, the focal length is positive. The distance of the object is positive, while the DI, it's either positive or negative. Okay? On the convex mirror, the focal length is negative. The distance of the object is positive, and the DI is always negative. Okay, please remember the sign convention for the mirror formula. Okay, let's go ahead. Let's now proceed with the mirror formula. Here's the mirror formula. 1 over F is equivalent to 1 over DO plus 1 over DI. Teacher, ang hirap naman po ng formula na yan. May fraction. Okay? Last year, no, the grade 10 is telling, teacher, fraction yan. Okay? So, here, F is the focal length. The DI is the distance of the image from the mirror. And the DO is the distance of the object from the mirror. Teacher, can you teach us already, for example, if we're going to compute for the F? Okay, what is the formula for F? Because that one is 1 over F still. What we will do, anyone who can derive this one? Huh? Who can give me the formula for F? Let us see if you can get. Who can give me the formula for F, my dear people of the Philippines? Try to check. Okay, I'll give already. Of course, because if I will wait you, it will take time. So, allow me to use my other camera. Okay, this way. I really want this one in the blackboard. No, but happen that you can see my pen. I have a pen. I have an apple. Okay. So Alex, na I'm hungry already. So F is you can see my handwriting. Okay, F is equivalent to DI times DO all over DI plus DO. So that's the formula for F or for the focal length. Okay? Focal length is equivalent to DI times DO over DI plus DO. And teacher, what about the formula for DO or D sub O? What is the formula? So we have F times DI all over DI minus F. That's the formula for the DO. Okay? And the last one for the DI. Who can give me the formula for DI? Sige nga, tignan ko kung magaling to, kung makakasunod. Can give me the formula for DI? So we have F times, if here is DI, then here is what? DO. Okay. That's DO all over We have, if here's DI, then here is, ayun naman pala, si Densulo. DO minus F. So here are the three formulas so that you will not anymore to derive. Okay? Is it clear, my dear people of the Philippines? Huh? Did you get already? I hope you get already, huh? Okay? So let's get it on. Let's have already problem solving. Let us see if I have already problem solving here. So remember, DI is distance of the object from the mirror, and DO is the distance of the object from the mirror. And F is the focal length. Okay, let's try one problem. Okay, so no need that one. So focal length. So doubling doubling the focal length gives you the radius of curvature. Okay, so meaning to say, half of the radius of curvature, we have the r sub c is equal to the focal length. So the formula, if it is double the focal length, and to give you, for example, they're asking you the radius, and the given is only the focal length, then multiply double the focal length. And that's the formula. And if it is half, then divide it by 2. The what? Radius of curvature. Okay? Clear already here? Let's get it on. So let's write here the formula so that if it is computing already, later on, you will we can see. Okay? And then for the half, we have the focal length is equivalent to RC divided by 2. Okay? So let's get it on. Let's have the formula or the sample problem. But before that, let's proceed to magnification. Okay, I think I discussed this magnification last time. Now we have one example. So magnification tells you that the change in size or height or magnification of the image relative to the object and image distance from the mirror. So here's the formula for magnification, where M is the magnification, HI or DI is the height or distance of the image. Typographical again, HO and DO is the height or distance of the object. Okay? So that's the one, huh? And it's written here, note that the height of the image will be negative if the image is inverted or real image. Okay po ba? This one is typographical. This is object should be HO and DO. So we have magnification, which is equivalent to HI over HO, and that is also equivalent to negative DI over DO. 1, 2, 3, 4, 5, 6. We have already 6 formulas. Okay? Now, let's try. I hope it's problem already. Example number 1. Okay? Here is the example number 1. Calculate the magnification of the image formed by a concave mirror if the height of the candle is 6 centimeter and the image height is 4 centimeter. It seems that I gave this one already last time. Correct? What's the answer here? 0.67, correct? Is that 0.67? No? Okay, that's 0.67. Okay? So, always remember, this one, I discussed also this one, remember? Did I? Okay. So, just to repeat. Here we go. Ala, ang dami pala. Okay? So, the height of an object is 5 centimeter and place 30 centimeter in front of a concave mirror that is a focal length of 20 centimeter. Calculate the following: the distance of the image, the magnification, the height or the size of the image. Okay? So, let's get it on. Let's solve this problem number 1. Okay, at first, let us get the following given in problem number 1. What are the given here? Can you? What are the given? What are the given here? Here. Jake, what are the given?
The height of the object.
Okay, the height of the object, which is the HO, that is?
5 cm and
Okay, 5 cm. Parang manganganak lang, no? 5 cm. What else?
ako pa rin po.
Ayaw mo ba, Jake?
Gutom na ako, sir.
Ha?
Gutom na ako, di na
Gutom
makapag-isip.
ka na. Ako din. Don't worry, we'll have our 10 minutes break. Okay, because we have Olympics in the elementary later. I'm so sorry, grade 10. Ha? Correct, grade 10. So sorry for that. But anyway, you can eat while having the class. It's fine to me. Tagarado. Basta makikinig kayo, ha? Okay, what else? Oh, Jake, sige, gutom ka na.
Ano po? Ay. Ano?
Gutom na si Jake. Tulungan nyo. Princess, go.
The distance of the image po is 30
The
centimeters.
distance of the image is 30 centimeter. What else, Princess?
The focal length po is 20
Thank
centimeters.
you so much, Princess. The focal length is 20 centimeter. Now, we're going to find the following. What are these things? Now, we have the... Please wait. And place in front of the distance. Okay, please wait. This is not the DI. It is DO, the 30 centimeter. Because it's written there, the height of an object is 5 centimeter and place 30 centimeter in front of it. So that is DO. We're going to find the DI. Okay. The magnification and the height or size of the image, which is the HI or SI, size of the image, height or HI, the size. Okay, so let's proceed. What's the formula for DI? DI is, anyone who can? Jordan, what's the formula for DI?
F times DO all over DO minus F.
DO minus F. Okay, substitute already. What is our F? 20 centimeter. Multiply to our DO, which is 30 centimeter. Okay, all over, what is our DO? 30 minus 20. Then, what will be our DI? Compute. $60. Okay, what's the unit? Don't forget the unit. Okay, we have 60 centimeter. Okay, so our DI is equivalent to 60 centimeter. So this will be that is the distance of the image. Okay, now let's go to number 2, the magnification. Okay, magnification. Okay, what's the formula for magnification again? Magnification is equivalent to HI over HO. But we cannot use the HI over HO because we don't have the height of the image. So what is the one that we will use? M is equivalent to, anong gagamitin? Okay, negative DI over DO. Okay, so go compute. So negative 2. So our magnification is negative 2. Okay. So what about the others? What's your answer? The same with the other? Negative 2 also. Okay, so we have already magnification, which is negative 2. Later on, let's describe this one, Okay. When we got, okay, hindi ko na patatagalin pa. Some of you answered negative 2. We got negative 2 already. Okay? Now, let's describe the image if it is negative based on the magnification. Huh? Again, last time, no? Going back to this part, okay, if the magnification is negative 2, then what can you say about the image? It is real according to Sarah. Okay, what else? Huh? What about the size? Of course, you cannot determine still. Let's go first with the height. No? Okay, let's check with the height. Okay, now how are we going to find the HI? How are we going to find the HI, my dear people of the Philippines? What is the height of the object? Isn't it we have the formula magnification is equivalent to HI over HO. Now, you need to derive this formula. Okay, and what is the formula in order to get the HI? Huh? What's the formula? Yes, who's that one? Aldea, Manipon.
HI is equal to M times HO.
M times HO. Sir, gutom ka na rin. Okay, so HI is equivalent to magnification times HO. Now, let's substitute our magnification is negative 2, multiply with our HO, which is equivalent to 5 centimeters. So, what is our HI now? That will be negative 10 centimeter. So that will be our HI, the negative 10 centimeter. At least you're following. Okay, any question regarding with this one? So look at the height of the image. It's negative here. And the height of the object is 5 centimeters. So meaning to say, what can you say about the size of the image if it is negative? It is, this is negative 10 and the height of the object is 5 centimeter. Very good. It is smaller than the object. Very good, my dear people of the Philippines. No? What about the distance of the object is 30 centimeter and the distance of the image is 60 centimeter. Then what is that one? The location. No, not location. In terms of distance, so it's very far in the mirror. Correct? No? Because 60 centimeter and the object is 30 centimeter only. Okay? So, that's the one. Okay? So, type of image. What is type of image here? Anyone who can tell me type of image? Since the magnification is negative, then that will be what? Good. Yes, it's real. Very good. Thank you so much, Kate, Gian, Jordan, Cyril, Joshua. Okay. Now, I get another paper so that we can proceed already with problem number 2. Is the problem number 2. A 4.0 centimeter tall light bulb is placed a distance of 45.7 centimeter from a concave mirror having a focal length of 15.2 centimeter. A. Determine the image distance and the image size. Okay? So what are the given in the problem? Let me hear the voice of Royce. Roy Banyares. Roy, what are the given here in problem number 2? Hello, Roy.
Sir, the ano po?
The ano?
HO is 4.0 centimeter.
Okay, we have the HO which is 4.0 centimeter. What else?
And the DO is 45.7 centimeters po.
Okay, 45.7 centimeter.
And depth is 15.2 centimeter.
15.2 centimeter. What are we going to find here? We need to find the DI, okay, and then the size of the image, okay, or HI, SI or HI or SI. Now let's go. Let's find the DI. Formula, please. What's the formula for DI? Centimeter. That will be our DI. Okay? So look at the distance of the object. Oh. It's 45.7 and the distance of the image is 22.78. No, teacher, bakit lagi magkaiba? Because we're using concave mirror. This is not a plane mirror. If it is plane mirror, remember, DO and DI are equal. Okay po? Let's get it on. SI or HI. How are we going to find this one? How are we going to find the HI and SI? So, meaning to say, we need to get first what? In order to get the SI, what we will do is get first the magnification. And what is the formula for this magnification in order to get the SI? So, we can use the DI and the DO. Okay? We have negative DI over DO. Substitute. Have negative 22.78 over our DO 45.7 centimeter. Then compute our magnification. What is our magnification now? Zero point 0.50 centimeter. Okay? Do we need to put centimeter here? We're talking about magnification. Yes, negative 0.50 centimeter already. That will be our magnification. Okay? Then, that's the time that we can find the SI or the size of the image. And what's the formula for SI? We have, just like what Aldea said a while ago, magnification times the height of the object. Okay, this one, it can be, the SI can be HI also. That is also equivalent to HI. So we can compute our magnification is negative 0.0, negative 0.50 centimeter. Multiply with our HO, which is 4.0 centimeter. Then what is our HI or SI? What's the value of our SI? Ang bibilis naman ito. Okay, we have 2 centimeter with our, okay, very good. Okay, we have 2 centimeter. Then upon checking, look at the magnification. It's negative 0.50 centimeter. What can you say about the object? Not negative 2 centimeter. Yeah, with negative. Okay, that will be negative 2 centimeter. Okay? Thank you so much, Aldea. Okay? Upon checking with the magnification, my dear people of the Philippines, what can you say? It is negative 0.50. What can you say about the image? The image is what? Hmm. Hmm. Uy. Naku, gutom na. Smaller. Yes, it's smaller. Okay. Type of image. What's the type of image? Huh? Real also. It is inverted. Now, thank you so much for those who are answering. I don't know if I still have problem number 3. Okay. Problem number 3. Oh, there's still more. Okay. I think I have a lot. Don't worry, this is the last. Thank you so much for who are answering. Up to 12 only since we reached this computation so that you will not have the problem in the exam already. Okay. So let's go with the problem number 3. So can you please read problem number 3? May I hear the voice of, who's the one I'm not yet calling here from the grade 10? Those who are not yet talking. Luis Cruz. Luis? People, you can eat ha while we're having class. Go, Luis, please read the problem. Ako na. At nagutom na si Jake. Ang bagal ni Luis. A 4.0 tall light bulb is placed at distance of 8.3 centimeter from a concave mirror having a focal length of 15.2 centimeter. Determine the image distance and the image size. Now, at this moment, I'll let you to solve that one. Okay? I'll not be the one. You'll be the one already. Practice already, guys. Okay? You'll be the one to solve. And then, put the answer in the chat box together with the image distance already and then the image size. Ha? So, do it. Do it. Do it. So again, if you're done, you can type your answer here, ha? Letter A and letter B also. Okay, before you will get the image size, please check the magnification first. Then the rest of the slides, if you still have problem solving, that will be your activity already. No? Later on, you do the screenshot. Since slide number 24, this one, and I have still up to 31. Okay? No one is typing. Don't like to finish. Yes po, Nathaniel. Both already. Okay, so DI is negative and HI is negative also. Okay, let us check later. I'm waiting for the others to answer, guys, ha? Some of you may be confused with the HI since magnification is negative times the negative. So it will be positive already. That's why your HI this time will be positive, not negative. Okay? Maybe you use that one, you forgot. That's the general formula negative. So if the other one will have negative, you will not copy that one. So negative times negative will be positive. Don't be confused with that one. Okay? So the answer for our image distance is negative 18.28 centimeter. And your image size is 8.81 centimeter. That will be the answer. Congratulations. Now, teacher, our DI is negative already. So meaning to say, if the DI is negative and the image is 8.8, what can you say about to our image? Can you check your magnification? What can you say about our image? The height, always positive. Sir, what do you mean height? Is it the height of the object or height of the image, Nathaniel? In the both, always positive. Height of the image, if it is magnification, that will be negative. Okay, is it negative HI or negative sorry, DI. Okay, that's DI. HI is always positive, yes. Okay, the one in the formula. Okay po? Yes, both HI and HO. Okay, so thank you so much. Okay, now I think most of you got the correct answer, but some of you confused with the HI. Okay, so the next slide will be your activity already since it's already 11:58. Please do the SS, no? Not social security system, ha? Screenshots. Do the SS with this one. Okay, here's the problem number 4. Please check or do the screenshots. If you're done, please do the thumbs up so that I can go with the next slides. Thank you so much, Antoinette. Okay, this way. Okay, let's get it on with the next slide. Here's the number 5. Oh, they're asking you about the radius of curvature here. Remember, actually, it's very easy this one. Let's answer the number 5 you want. You don't na. Ako dito, Sarah, hindi na. Sagutan natin yung activity na lang. Okay, next. Let's go with the next one. Okay, this is number 6. Done? Number 7. Ang dami naman ni Sir binigay. You know why I put a lot of things here? Because before, most of the students are having problem with the formula. Only this time that I gave the formula, the DI, DO, and F. Look at my PowerPoint presentation is only the general formula, remember? So dahil mabait ang 10A, I gave already the formula for DO, DI, and F. Okay? So anong gusto mong paratingin, Sir Alex? Magpapasalamat kami. Okay, number 8. Wait, no more. Anyway, here is the example of the concave mirror, no? Actually, we already talked about this one a while ago when I asked you the different uses of the concave mirror, example or application. And here is also the example of the convex mirror. Okay? That's why if you will notice, no, in the ambulance, it is inverted, no? That's why, and then you can see the writings, no? If you will, so that if you will check in the convex mirror, it is very big, the letter, and what? The word ambulance. Upon checking in the side mirror, you will notice you can read it properly. Gets? No? So that's why the word ambulance is like that, so that if you will see in the mirror, you will the driver will see that there is an ambulance. Okay po? Any more question with the focal length DI and DO? No more question? Okay, so since Cyril is talking to someone, Cyril will be the one to lead the prayer. Go, Cy.
In the name of the Father, and of the Son, and of the Holy Spirit, Amen. Bless us, O Lord, in this gift in which we are about to receive from thy bounty through Christ our Lord. Amen. In the name of the Father, and of the Son, and of the Holy Spirit, Amen.
Gutom na talaga si Cy, no? At si